All right. Are we live? Okay. So welcome to today's live stream. It's been a little while. It's only the third one I'm doing, so I'm still trying to get a hang of things, but feel free to comment and I'll try and notice and reply. Um, this week I was very productive with working through some issues and some things that were on my to-do list for a little while. But I forgot to stream it because I'm not used to this yet. So I thought it would be interesting maybe to review some of what was accomplished, and hopefully that would be of some interest. We meaning mostly I, but with some help from people in the community, um, improved the documentation of our Caddy JSON docs, which I'm happy with because these documentation pages are in Markdown, but we have a few pages that are powered by a database backend, and that's mostly the module and our dynamic config structure documentation. So we have a page here that lists all of the modules that that you can include in your Caddy builds. The green ones are included by default. The yellow ones are extra that aren't shipped as part of the standard distribution. And then we have our infamous JSON config structure that documents how Caddy's native configuration looks. So Caddy is by default configured with JSON, and this structure is complex and extensible. So at its root level here, there's just 4 keys. Admin configures how Caddy is managed and how its configuration is managed. Our logging obviously configures logging. Storage configures kind of Caddy's global, like how it stores assets and other state that it needs, and then apps, which actually is how Caddy does things that you want it to do. For example, the HTTP server. So these 4 keys are pretty simple and important, but you'll notice that while we can expand some of these, like admin, and we can see various keys and values that you can configure, and they each do something kind of useful. Some of these have dots next to them, and this is where Caddy is interesting, because these values can be filled in with kind of almost arbitrary values. This is what makes Caddy so powerful and extensible, because where there is the possibility of being able to do something multiple different ways, you can just plug in that capability and then just configure it here. And so documenting, this is not a static configuration structure. This is very extensible and kind of dynamic based on code that you maybe or other people write and then publish and register on our website. So we have a database powering this backend. I just migrated it from Cockroach to Postgres because Cockroach is a really nice piece of software, actually. It's written in Go, and that was its main appeal for me. So Go programs are easy to deploy and manage, and Cockroach had a nice kind of monitoring UI and stuff, and I loved how simple it was to just get it running. The problem is that recent changes in Cockroach have made it difficult to get data out of Cockroach in like a simple way, and none of the tooling I was using was like supported a lot of these operations. And I tried multiple various database clients, some of which were designed for Cockroach and just really buggy and like immature implementations, or even more mature ones like dbeaver that just a lot of limitations in their Java libraries. Or, Cockroach is supposed to be Postgres compatible, but it's only like mostly Postgres compatible. And anyway, it was just enough rough edges that I decided to switch to Postgres, because it was really difficult for me to get a production copy of the database on my local machine. Anyways, So this database is powered by now Postgres, and yeah, the Go code for generating this documentation is really not a lot of fun. I hate kind of messing with it. But in this case, so the problem was that because there's a lot here, and so actually, if we zoom in here, so here's the HTTP app. This is the HTTP server, and this is a complex config. There's a lot here, and the documentation is even like more verbose. Like there's just a ton, and this is all generated from comments in the code. And from the database and the and my documentation backend, they're putting all the pieces together and rendering the CUI for us. And so, if we drill down here, for example, we want to configure servers with routes, so HTTP routes, and we want to handle requests with the reverse proxy. We come all the way in here, and you can see how deep we are in the config already. And we have, as we hover, we can see all of the other possible values that we can, or keys in these spots in the config. So this is like our breadcrumb structure that shows us where we are and where we can kind of jump over to. And so this, let's see, so this is really actually complex to render because this is these are recursive structures, and some of them, the recursion is terminated when you hit either all static, like either non-array and non-structure types, or you hit like a module type where you can plug in a module. So that terminates the recursion, but basically what was happening is that a page like this is the JSON docs for the reverse proxy module in an HTTP server route, was taking up to 30 seconds to load. So there was this issue here. This guy says over 10 seconds. I had seen cases where it was closer to a minute, and I think some people reported it as being up to a minute. And that was because at some point I fixed a bug by removing some caching on the server side, and like I added stronger versioning, and like I improved the backend, but I also slowed it down. And I didn't have time to go through until just recently and like speed it up again. And so I wasn't really looking forward to tackling this, and until finally this week where I decided it was time for the pages to be able to load faster. And so the first thing that I decided to do was look at some of the low-hanging fruit. Let's see, Sarge on our community, he taught me about the explain command in Postgres, and that if you just prefix a statement with explain, it will show you kind of how the query is being evaluated. And I guess maybe I can show you that here. Let's see here. Can I show you this? Postgres local. We'll see if this works. Caddy, public, tables. Types, data. So this is an example of what the database looks like. This is my local copy, and you can see here. Whoops, I don't actually know how to use this tool, by the way. Let's see, SQL, recent SQL script. Whoa, there's the schema, if you were wondering. Not very interesting, honestly. But it's like explain, and then, let me go ahead and pull up some of the code here. So this is I recently rewrote a bunch of these queries. And so handlers, so docs, handle get docs. So this is the handler that would get the documentation. And so I was like, okay, well, where is it slow? And I just wanted to show you, so load type by path. So get type by name. Oh yeah, type by name. So pretty simple. Okay, yeah, so here's a pretty simple query. Don't mind my really awful, I'm not actually really good with databases in Go, so just don't judge my code, okay? Select server package path equals github.com/parent server/caddy/v2. Actually, let's do let's do 4 and name equals what do I call this? Actually, I don't know what this is called. Hang on. Database tools like this are really handy, but boy, they can be modules. Layer 4, yeah, modules proxy. Let's just do that one. Oh, just there. Okay, so here's an explain statement, and you can see that it's limiting to 1, and it's doing an index scan and an index condition, and that's great. The problem is that initially this was doing a sequential scan, and so I realized, oh, I need to add an index, and I realized that there weren't indices on this table where there needed to be, so I added a bunch of indexes in indices on name and package path columns and version columns, and the structure column is a JSON document, so that's using a GIN access method. I read about that on the internet and I don't understand it, but it's apparently what you need to use if you want to index into JSON types. But anyways, it was adding version, name, and package path. And I noticed that by adding these indices and then reloading, just move that over here, reloading this page made the page load times, and again, I was just doing like the network inspector here and then just looking at the timings for this request and looking at time to first byte, and this is the finished result now, but the time for my local computer was like 4.9 seconds, which on the production server, which is much slower and busier, it was like over 10 seconds, sometimes 30 seconds. And it got worse the deeper you were in the breadcrumb and the bigger and more complex the modules and stuff. And especially so if you're in like a huge module like the HTTP app, you know, there's all these things that it has to load data for. And anyway, adding those indices actually took the time from 4.9 seconds down to 2.9. So I already trimmed off 40% of the load time just by adding a few indices, really easy. The next question was, what can I do in the code to improve the performance? So as I looked at this handler, I was like, okay, first we are building the breadcrumb details. So for every part of the path, we were loading the paths or that part's type and adding it to this breadcrumb. We're accumulating a breadcrumb basically. And by loading the type at that part of the path, it gives us like the name and structure. So it gives us, basically these names here. So that you can, instead of having to like, if you wanted to say, oh, I don't actually want to look at the reverse proxy module, I want to look at this module, you don't have to like hit back and then scroll and then click again. You can just hover here and click. The problem is that this was very, this is very repetitive. And so when we were doing this, adding the indices here helped a lot. So it wasn't scanning n squared. Basically, it was more like a maybe log n type of improvement using an index, and And then, so what I did is I realized this part wasn't the slowest part, and this is easy to test by commenting it out and just seeing if the page load time changes very much. So I would do that. I commented out this next part where we get the details of the actual target type. That there's not much we can do about that because that's the whole request. The whole point of the request is to get this information. And then also loading the modules. And notice here I call get possible modules twice because I have to get possible modules for the current structure that the page, so this page here, so all of these placeholders where there are modules that can be used, we have to load these. But then we also have to go through and get the possible modules for the breadcrumb. And that's because, for example, handle takes modules. It's not like a struct field or like it's not a static field. And so all of these listed here are modules that can be used here. Same here with apps. Like these are all modules. These aren't hard-coded into Caddy. These are all things you plug in. And so we have to go get that from the database separately. And by using a query that can get the possible modules at this place in the structure. And so this function is called twice, once in a loop. Well, it's called once up here, and then it's called the other time is in this loop for every part of the breadcrumb. And that was key. I noticed that when I commented out the loop, the page load times went down to almost instantaneous. It was virtually all the other overhead was in here. And I realized, you can see some commented code here, I left it here for demonstration, is that so this is a recursive function. We're traversing this recursive structure, this arbitrarily deep structure, and our recursion terminates when we reach an array, for example, or a place where a module can be used, and or not an array, but basically in any place where a module can be used, whether it's in an array or in a struct field or something, we terminate the recursion. And what we were doing before is kind of naive. I was basically saying, oh, well, for every, so this if statement wasn't here. And basically I was saying every time you reach a place where a module can be used in the config, go ahead and get all the modules in that namespace or all the modules that can be used in this place, and then add it to a map if it wasn't added before, so prevent duplicates. And that should have been an indicator to me, like kind of a red flag, like, wait, why are duplicates appearing in this in the first place? But I didn't think about that. And notice how this was in a for loop, and this is in a recursive call. It's just lots of, and get modules in namespace. This is a database query that used to be even more expensive. I also simplified this by getting rid of subqueries and using a select distinct. To deal with the problem is dealing with versioning. You have to get an order by, you want the latest version. We have the capability of showing specific versions in the docs. We just don't expose that yet because that's more work, but you can know that the docs are strongly versioned. Right now we're just showing the latest version of everything. And anyways, so this query was being run, actually this one is being run a ton of times. And where was I? Because it's being run in a loop in this recursive call, and I didn't think about this at the time, but what I was doing is I was calling this, like, once you call this for a particular namespace, we add it to this map, which we carry through. It's our state that we carry through the recursion, and we don't need to keep re-adding this. We don't need to keep this doing the same query for the same namespace and adding it to the map. We're going to be overriding the same value in the map with the same values over and over. We shouldn't need to check for duplicates. So, basically just, if we don't already have information about this namespace, then get it once, just once. And we don't need to check for duplicates anymore. Add it to the map. And we also do that down here if it's not an array, but if it's in a struct field. Similar kind of check here where if we don't already have information about this namespace, then get it. Otherwise, we don't need to hit the database again. And so we actually, I think we reduced the order of magnitude here pretty significantly. Yeah, because the old code and without this, so I added this if statement. I can probably actually, yeah, here's a diff. Yeah, so I added this if statement and I commented and removed this. And so that improved the efficiency pretty significantly as well. And anyway, I don't know if this is making any sense, but that got the page load time down to, I documented this here, basically less than 900 milliseconds. In practice, it's even faster. And I think if a page takes longer than a half second to load, that's probably a bit rare now. And so you can go really deep in this config structure, by the way. Handle, reverse proxy, whoops, vars. I actually meant subroute. But we can go kind of really deep. I do hard code a limit. So subroute is basically you can do this infinitely. I do hard code a limit on the docs. You can't go super infinitely. But even this, with all these breadcrumbs it has to load, our load time is only 460 milliseconds, which is not great. But for documentation pages like this, that's way better than 10 seconds, 30 seconds, especially because the plateau does seem to be around 400 to 800 milliseconds. And that's because of, again, improving the database queries, removing those subqueries, and fixing the code so the recursion was amortized and we actually remembered our state rather than getting it, we only had to call each of these queries once, and adding indices. All of those makes this much faster. And as a icing on the cake, we also, you'll notice that I just added a response header here, cache control max age 3600. So if you're just clicking through, browsing the docs, going back and forth, I could probably increase this to a day or even a week because it's not like these change that often. The page loads should be pretty much instantaneous. Well, when I don't have the dev tools open, cache disabled. So your future visits to a page will be instantaneous because your browser will remember. So anyway, there, we improved the efficiency of our documentation pages by 98%. Or we reduced 98% of the loading time, I should say. So it's probably what, a 10x improvement in speed at least. So that was fun. Thanks for those who contributed in with their ideas here, and yeah. Okay, so here's an issue that, a request that the FastCGI client be moved into its own package. So this is an interesting idea. I haven't seen many libraries for Go FastCGI implementations. Let me close this out here. CGI client. Caddy is a FastCGI client when it reverse proxies to a FastCGI responder. So if you're using a PHP app behind Caddy, you are using this client code. I did not write this client code. This actually came from, I forked in 2015 from a Bitbucket account called PinIdea, which was forked from a Google Code repository. And the copyright on it was Junqing Tan, and we have iterated on this a bit, but we haven't ever rewritten it. And it served us well, but it does need to be rewritten. And so my response to this person was, sure, that's a cool idea. I guess you could use it as a library for other applications, however, not in its current state, because we have this issue 3803 where FastCGI code does need to be optimized. It needs to be improved here. And let's see. Hang on, I'm going to open this a little bit. Okay. The problem is that it's not a very efficient implementation. There's a lot of allocations, a lot of buffering, And I have tried, I started, like, I tried to add something simple like buffer pooling to improve its performance. The problem is that the current way it's written doesn't really, like, the way that it's record type and the FastCGI client type are written doesn't really. I think I have a branch for this somewhere, or FastCGI client refactor. Can I switch this? Yeah, so I tried this once, and can I see like a diff? Initial attempt. Yeah, so I tried adding some pools here to the FastCGI client and um, uh, trying to make those pools, yeah, be able to return writers. So the way that the relationship between the client and the writers is not conducive to pooling buffers. And I don't remember the details anymore. This was 10 months ago that I committed this. And I think it was longer than that ago that I actually wrote it. I had it stashed for forever. Um, I was not able to implement pooling with the current code. It would basically need a major refactoring because, yeah, the way that state is stored and carried around doesn't work for pooling very well. At least I wasn't able to figure out a way. So this is an open issue. If anyone would like the challenge of implementing a faster FastCGI client that is more efficient and is willing to refactor this and maybe even just rewrite it with efficiency and kind of an exported API in mind, that might be really awesome. I would do it. I just don't have a ton of time. It's not a huge priority, given that this is something anyone can do. I try and focus more on the really Caddy specific things that kind of only I, like someone like me with my vision for the project, I guess, can do. I think this would be fun, and maybe someday I'll get around to it. But I think it'd be faster if someone else did first. So, anyway, there is that. Okay, I have a ton of issues I'm behind on right now. There were a couple of interesting ones here, but first I want to show you this topic in the forum where we had worked through recently a kind of a weird bug in cert magic, and I really appreciated this guy's let's see, activity. Yeah, this one here. He reported this strange behavior, and I think I went through this in a previous stream. It was the case of the mysterious disappearing certificate. And oh yeah, I did explain this. And so that's been fixed, which is nice. But now he's seeing an invalid memory address or nil pointer to reference using the latest changes. And these aren't, it's not particularly serious, but it is something that we need to fix. And because of other stuff this week, I haven't had a chance to look at this quite yet. But basically what's happening is that this function is trying to do an interface conversion, and it's nil, not an Acme authorization. Oh yeah, so I identified the source of the panic, which is coming actually from Acme Z, which, I don't know, I'm kind of proud of this library. This is a hand-rolled Acme client that I think is some of the most elegant code I've ever written, and it's very well documented. And so I also reference the, I think it just has a really nice API, and I reference the Acme spec a lot in the comments. And anyway, so it's doing this interface conversion because there's no check, like OK check. It has to succeed. The problem is this value is being nil. Well, I thought, okay, that's weird. So I guess Let's Encrypt is always filling out the problem field. And it typically happens for authorization errors, and so this is probably an assumption I'm making that I shouldn't be. But there's also this case where so he's getting this error where the cache is full evicting random certificate. This is normal. This happens when you have a lot of on-demand managed certificates, and Caddy just has to evict one to make room for a new one that's being used. Usually, though, there should be a subject or a name on the certificate that it's removing, but this one seems to be empty, which is weird. It's making room for this domain name, but there should always be a subject name in the certificate or a name of some sort. And the fact that it's empty, especially for managed certificates, is weird. And so maybe a couple things going on here. And so I haven't looked into this yet. I don't know right now what's going on. But apparently, and I can go down here to some code. Let me open up Cert Magic. So basically what happens is, in our certificate cache, we store a bunch of these certificates. And they have an embedded TLS certificate, but we also store some other data because we need it when we manage certificates. And the name of the certificate should be filled out. There's a ton of references to this field. We use it all over the place, which is one reason this makes it hard. You can see that we do assume in a lot of cases that, oh, no, here we do a check. But generally there should always be a name in the certificate. And so the problem is that the panic that he's reporting, as far as I can tell, is not necessarily coming from this line. It's, oh, here we go. No pointer dereference, server.go, panic.go. Okay, remove certificate. Looking for like a line number. Line 281 in cache.go. So if I go to cache.go and find line 281, oh, and I need to use the same version. It's clearly, though, it's some reference to cert.names. And oh yeah, so this is where the empty array is coming from. The actual panic, though, cache.go line 281. Am I missing something here? Remove certificate. Panic. Because this should be the latest version already that I'm looking at. Go. Move certificate. Cert magic. Cache line 281. So yeah, this error report was it's very useful, very helpful, and I think it's well researched. I just need to investigate more why a certificate in our cache has an empty names array, and kind of how that's possible. We do, I mean, yeah, I'm not sure. Maybe there's something getting out of sync. We actually have an index in our cache of name to a certificate hash, and I wonder if something's getting out of sync there, or what the issue could be. I'm not exactly sure. I probably won't dive into this right now too much because I want to keep the live stream somewhat interesting. And I won't bore you with this right now. It'd be a lot of me just scratching my chin, figuring it out. But that is an issue that I'm working right now. One more really quick issue that I thought was kind of interesting that we looked at this week. Well, I don't know, there's a couple here. Actually, okay, this might be interesting. So this person is extending the logging capabilities by adding some sort of basic auth filter, a log field filter that filters the username out of an authorization header and logs it. And he has a use case for this, and he wants to see the username in the access log. So, which I thought we'd do this already. Fills in the user ID in the structured log if it has done the authentication itself. Oh, that's true. Yeah, so, okay. Yeah, that's true. We don't parse out the authorization header and log the parsed values separately. We can log the authorization header, but we don't like parse out the base64 encoded basic auth. So he's writing a module to do this. He's wondering why this code is changing the request. Apparently, it logs fine, but the login extension actually changes the authorization header of the request. And looking at it, it was fairly obvious. I think it's fairly obvious to me. The filter, what it's doing is it's doing a interface conversion. It's converting it to a loggable string array, which is a type that, okay, let's see, package.go dev Caddy HTTP type loggable string array. It's just a slice of strings marshallable for logging. So it implements some Zap interface. It's just a string array. And what they're doing is making a fake request so they have access to the basic auth method of HTTP request, which parses out the credentials, and then it's setting that user ID in the auth header. So here what it's doing is it's basically accessing he basically wants the authorization header to contain, it looks like, the user name instead of the actual authorization, basic auth value. But notice that by indexing into position 0 in the array, they're overriding there's no copies going on here, is basically what I'm saying. You're converting this so that you can access the data in a type-safe way as a string array, and then you're changing a value in the string array, and slices and go are pointers to an underlying array, and so it's just pointing to the 0th, the first position here, and setting the user ID on it. So I'm not super surprised that it's changing the authorization header of the request, because that's essentially what this is doing, is you're kind of forcing your way into the type here. You're making it not generic, and you are, so basically his question is, yeah, it's a great question. Is he doing something wrong? Not necessarily. If he doesn't want to change the authorization header, then don't change the authorization header. Why can the logging filter change the request? Well, it's because this is what happens. You can, there's enough rope to hang yourself, I guess, where you can do a type conversion and brute kind of force your way into changing values here, and sure, you can do that. Logging happens after response is sent to the client, right? Yes, but there's not a copy of the data here. You would have to, the safe way to do this would be to copy if you're going to try and access this opaque interface value in a type safe way as a specific value and then change it, you need to make a copy of it. So logging to 0 allocation, that's true, but doesn't it seem dangerous if a logging module can interfere with the actual request? Yeah. Don't do that. You would have to do a copy, I suppose, if you're going to be doing that. So this is an example of maybe using values and the interfaces and APIs here in a way that's not intended. Maybe, I don't know what the Zap documentation says, but maybe it says something like, don't do this. Maybe it doesn't, but I think the idea is just be wise when you're going to do type conversions and be changing stuff. If you don't want to change the original underlying array, then make a copy of it. And does that mean it's no longer zero allocation? Yeah, but that's also because you're slapping a filter on top of these logs, and so I don't think that's too surprising. Anyway, is there a way to add new fields to structured log from third-party Caddy module? Maybe? I don't remember. I have to look into that more. Yeah, Zap is kind of fun that way. Okay, last little thing before I wrap up here. Make this less than 45-minute feed, or a stream. So this guy has a Caddy file where he's using the map directive and is trying to use regular expression. So basically mapping the host or the host name of the request, and if it ends in .net or .xyz or he wants to set magic number to 7 or 15. The problem is that, and then, so basically, based on the host, if the host matches some pattern, they want to set this placeholder and this placeholder to be some values. And you would expect the result for to be abc99. I'm assuming abc.localhost. So if the request host contains abc, then set my placeholder to capital ABC and magic number to 99. And so you would expect then when you set the map result header, it should be abc/99. But it's actually abc.localhost/99.localhost, and that is weird. And so Francis was able to reproduce this with a simpler Caddy file and found that we're using replace all string. And when I finally saw this issue, I was like, wait a minute, why are we doing that? So the regex package is not my favorite package. Regular expressions are not my favorite. So I did fix this though, and because I realized, so as we were, so here's the handler, the map handler, and we take the input value, in this case the host name, and we evaluate the placeholders, and so we get the actual placeholder value, and so it would be abc.localhost in this case. And then for every mapping, we look and see if the input matches this particular mapping, I guess. So if, let me go up here to the original. So basically we look at the evaluated host, which is abc.localhost, and we get to this regular expression. Oh, it matches because there's an ABC in it. So then we used to be doing, and I wrote this code. I take full responsibility. I don't know why I wrote this line, but apparently I was replacing values on the input with the output values because it expands the regular expression like placeholders. So if you want to use like capture groups, you can do that. But I was doing it on the input, the host name, which doesn't make any sense because what you really want to do is you just want to basically evaluate this string. Here there are no expansions, but here there is one. And so you just want to evaluate this string. There's no replacements going on, just expansions. And so I was like, which one of these functions is what I need? And I found this expand function and expand string, but it's kind of awkward because it still deals with byte slices even though we have strings. And thankfully they have an example. I'm like, okay, this kind of makes sense. So I just changed this example and basically make a output slice for the result. And then for all the submatches in find all string submatch index, which I got from the expand function documentation, it says the match slice should have been returned by find submatch index. So there's a lot of like pieces you kind of have to put together here. It is kind of a weird API. And then you say the result is equal to expand string, and you pass in the current result so far, the accumulated results, and then the string you want to expand, and then the input that you matched from, and all the submatches. And it's been a long time since I've studied this stuff in school, but apparently this is what you're supposed to do. So this is just kind of a silly like duh moment. And oops, that is the wrong. Here we are. So I said, hey, I fixed it. And he was like, great, it seems to work except for one result where the destination is concatenated multiple times to the value. He expected 3, but he got 3, 3, 3, 3, 3, 3, 3. Oops. So I would need more information, but maybe I probably did something wrong. So I don't know. I guess we'll just have to see. But that's fun with the regular expression package. So that's all for today. I hope this was kind of interesting. Sorry, next time maybe I'll try and remember to do some live like streaming while I'm coding, while I'm actually fixing the problems. And yeah, I hope you'll tune in next time. Let me know if there's anything I can do to improve these, and have a great day.